But I'm really the table setter today. When we started using 1080, we were in a crazy time in the year, and I said to Yas and Ian, I said, you guys are nerds in the best possible way. Take the lead with this. And my job is to just support you and be a part of this. So in a lot of ways, I'm going to set the stage for what these guys are going to talk about. So think of our presentation as kind of 3 TED Talks that are a little bit staggered. And really what I want to talk about is how we batch. This is something that's probably not just an important lesson for what we do at CSP, but also through my role at the Yankees, where I want to say opening day 2024, we had 277 guys in the organization. Some of them rehabbing, some of them healthy, some in the Dominican Republic, some at an affiliate, some in the big leagues, some who are early draft guys who are in the FCL or in extended spring training. So you have people at all different levels. So we try to batch them accordingly to make programming more efficient. So for what it's worth, this is our first facility. This is the first picture ever taken in the history of CSP. This was July of 2007. It was this beat up warehouse in Hudson, Massachusetts that also was part of a baseball facility. If you got too close to this, you needed a tetanus shot. But what it speaks to is in that moment, I told my business partner, Pete, I said, our business model will never dictate our training model, right? You see it in the context of safety squat bars, and a Proteus, all these different things that you might use with overhead athletes. We wanted to make sure we designed a facility that accommodated this kind of athlete, as opposed to just trying to be everything to everyone. And certainly we have pro tennis players, golfers, football players, you name it, that train here. But baseball is the core competency, and it's probably what drives my mindset the most. So the last thing that you ever want to do when you're trying to chase a training model that serves a very core competency of your clientele is to make people average. So if you guys haven't read this is an amazing book. Todd Rose is I think he's a behavioral psychologist at Harvard. Awesome audiobook if you guys are looking for something for the ride home. But basically he said the real difficulty is not finding new ways to distinguish talent. It's getting rid of the one-dimensional blinders that prevented us from seeing it all along. We live in a world that demands we be the same as everyone else, only better, and reduces the American dream to a narrow yearning to be relatively better than the people around us rather than the best versions of ourselves. So I'm going to follow this up. I had Stu Miguel on my podcast. This is like 2019. For those of you who don't know, Ben and I were just talking about world's premier spine biomechanist, right? He's done hundreds and hundreds of studies and has a very different perspective than the modern medical model, right? Where somebody goes in with chronic back pain, they get seen for 15 minutes, the MRI shows a bunch of stuff wrong, and they punt on it and they don't get a good answer. When you see Stu, he could probably do 2 consults in a day because it's so thorough. He digs so deep on going through their history, how they get out of their car, how they walk into the building, how they get up, how they sit down. He really pulls a lot out of them. And I asked him, when you look at research, what is it that you're looking for? And well, his answer really surprised me. He said, I'm looking for outliers. Like I'm looking for people I thought would break that actually stayed healthy, or I'm looking for people that stayed healthy when I really thought they would break. If we think back to the Shelbourne classic ACL study, right? The people who weight bared when they weren't supposed to were the ones that had the best outcomes, right? So these outliers are what we look for. And in the baseball world, this is really, really important consideration, all right? And I use this study all the time. This was a study Mike Reinold, when he was with the Red Sox, basically did in conjunction with their team doctors. And all it was meant to do was look at range of motion changes after a pitching appearance, right? We know you go out and you throw a baseball, internal rotation during the baseball pitch is the single fastest motion in all sports, 7,000 degrees per second. So if I did this, imagine my humeral head going around 20 times in the matter of a second. That's how fast it happens. Something has to slow that down, right? So we get chronic changes in the muscles that break, right? The posterior shoulder muscles. So we always expect to see an internal rotation loss, an elbow extension loss, because all these decelerators are working really hard. So sure enough, they go and they look at it. Just for context, before 190 degrees of total motion, that's IR plus ER at 90 degrees, right? 54 degrees, 136, no surprise there. After, you lose a little bit of IR, you lose a little bit of ER, lose a lot of IR. If you go down lower, minus 8.3 versus minus 5.1. And then if you look 24 hours after, it's gotten a little bit better, but it's still there, right? So if you ignore preserving range of motion in the average pitcher over the course of a season, an elbow is going to start to look like this. That shouldn't surprise anybody, right? Anybody who's ever done 5 sets of 10 stiff leg deadlifts and woken up 36 hours later with really, really sore hamstrings, like you've lost motion, you've got to work hard to get it back. But the thing that nobody ever looks at in these studies is the standard deviation, right? I look at it and I say, all right, 190.6 degrees is your average, but you got a standard deviation of 14.6 degrees, and not everybody's within one standard deviation. If you've got a major league pitching staff, you're probably dealing at 13 guys maybe a tick more if you got a couple guys on the IL. There's probably one guy out there who's got 220 degrees of total motion. He's crazy loose, right? And you got somebody in the other direction who's probably living down at 150 and is as stiff as a board and needs to be way more challenged in different ways to preserve that motion. More manual therapy, more positional breathing, getting him in a dark room, getting him in a sensory deprivation environment, something to make it work. So if we just treat averages, we screw over the two that are at both ends of the spectrum. So it's been something that has always governed what we try to do at the facility here. And this is where a lot of these awesome objective initiatives can really help, which I'll talk about. But programming is really hard. Why? You know, we got guys like Matt who are blowing us up on social media with all these cool ideas that we want to try out, or you got information overload. You're trying to reconcile different schools of thought, right? We've got PRI, we got FMS, SFMA, DNS, all these different acronyms that are completely overwhelming us. And we go to a course like this, and the tendency is to want to go back and change the 100%. If this course is successful, you guys should go back and adjust 2 to 3% of what you do tomorrow. Like, it should be nuanced, right? It should understand how to use a great piece of technology a little bit better, or to do an additional assessment on that athlete that you might not have done before, right? You have to overcome your personal biases. I was a competitive power lifter for a really long time. Like, all I wanted to do was get guys strong early in my career. It's a big deal to host a 1080 conference at CSP. If you had met Eric Cressey circa 2011, this would have been hard to pull off, right? There's a complexity trap, right? You always want to write these hard programs. And then you remember you're staring at a 14-year-old kid that eats candy for dinner and has never lifted weights before, right? But objective data never lies, okay? That's something that is so important in today's world. You have more opportunities to collect it, and you have to use it intelligently. So how do we assess? There's always pre-screening, right? What our crew at the front desk does is massively important for setting all of our coaches up for success, right? I know that if someone needs to clean up their sprint mechanics, I'm going to Ian first and foremost on our staff. I know if I've got a weird collection of asymmetry, I'm probably going to take the evaluation. I'm going to have Yas pulled in for some of our data collection, right? We have a strength addition coordinator, we have a sports science coordinator. Just knowing who's going to take on certain cases is really important. You know, if I've got a female softball player that wants to go to the next level, Kaylee's my girl. She'll kill it. So preliminary paperwork, people will always underreport, right? You're going to dig deep on medications, previous injury history, especially in the era of filling out paperwork on an iPad. Nobody likes to type on an iPad. They'd rather write or type, so you see much less communication. So you've got to dig deeper when you actually meet with that person. You have that sit-down conversation. You pry. What's worked? What hasn't? What have you liked? What have you disliked? Where have you trained? What have they done with you? What technology have been exposed to you? Do you have a radiology report? Do you have, a 1080 report from a previous facility? All that. Then we'll go through some specific movement tests. These are our assessments. We have general movements tests, which are screens, right? They're very different. A specific one might be a shoulder internal rotation measurement or a hip flexion assessment, right? Something more general might be an overhead squat or an overhead lunge walk or a push-up that involves multiple joints and shows us how we sequence, more like links in that chain. Second tier assessments, right? Breakout, provocative. If I've got a hip, that stops short and kicks me out, I'm going to run a fader. I'm going to run a Faber test. And I'm going to see if we have a provocative hip, that doesn't do well with a lot of these FAI tests. And that's going to dictate a lot of what we do. Maybe I'm going to punt to Tara for some manual therapy. Maybe I'm going to do some banded distractions before we get to any of this. Okay? And then test, retest. If it sucks, let's try something and see if we can make it better, right? That stuff is really important. And then last but not least, the reason we're here today, right? Performance screens, strength, power, capacity, asymmetry. See how people actually get when you test them at higher velocities with more forces involved. This goes a really long way. What are the principles? You got to understand the difference between screens and assessments, right? If you got a large body of athletes, you're probably doing more screens. But here we like to get much more nuance. We like to work a lot more one-on-one with people to figure out what's appropriate for them. Look for red. I'll show you what this means in a second here. You want to identify maladaptation, right? We're going to talk a lot about infrasternal angle today across me and the other two guys in the first presentation. I know Kevin's going to talk on it, but if you've got a narrow infrasternal angle who walks in here and he's got 30 degrees of thoracic rotation and he's lost all his hip ER and IR, that's a guy who's maladapted to some of the training stimuluses that have been thrown at him. Consider referring out. If someone's dysfunctional and painful on a pattern, get them some treatment and then circle back and see if it's better. Right? Don't ever be afraid to refer out. chase the DNs, right? If somebody's dysfunctional, non-painful, their thoracic rotation isn't good or their cervical rotation isn't really good, but you can go and you can test it without it hurting, by all means, throw some stuff at it, see what you can clean up. And just remember that you do a comprehensive assessment to tell you if the juice is worth the squeeze, right? If I go here and it hurts, overhead pressing is probably not in my month one playbook for an athlete. So this is why we do something more thorough. And this is the second to last slide for me. Don't be afraid to impose fatigue. This is really important. We're in an era where everyone wants to PR every day. I have no care in the world what our guys look like in November. I care about what they are in February on. This is a major league reliever who trained with us. This was his third or fourth offseason with us. These were his numbers the day he got back from camp. He was one of the first pro evaluations, like the season ended October 2nd that year. So he took 12 days to get here. This was his first testing. So this is 3 weeks in, went to all red, right? Vertical jump went down, jump momentum went down, peak velocity went down, braking RFD went down. Literally everything went down. MRSI went down. His time to takeoff stayed about the same. And this is just what happens when players get back from the season and they go from baseball shape to weight room shape. It's totally fine. You want that. You have to impose fatigue to get adaptation. And guys will get freaked out about this. So you have to be really careful about getting too hung up in the numbers. But then you look at what happens. He had a bunch of travel for some weddings in there. This didn't rebound as quick. But basically, throwing starts in here. And by the time he got to February, everything was green. We're talking about a guy from a 16.7 to a 19 vertical jump while gaining weight. Jump momentum from 279 to 298. Career high in velocity last year, career high in appearances, put him in a great position. He actually sent me his numbers from his organization in March, and it got even better, right? This is delayed transmutation. Like what we do in here doesn't magically just show up on a baseball field, right? There's a time that has to take place. So this is where some of the 1080 stuff can shorten that change, okay? And this is something that's gonna make a lot more sense in a couple hours here, but if you do things well on the front end and you have the right objective data to carry it forward, it's gonna set you up for way more success in January and February as you lead into that season, okay? So how do you close the loop? You've got to determine your priorities, and we're gonna learn a lot about those today. What really matters to you? You always document like crazy. This is the one thing that has probably helped me the most. I was an accounting background before I got into this. I thought I was gonna be the 6th accountant in my family. I'm a numbers guy. I document meticulously, and it has never served me wrong. So for those of you who are just like scratching it down in a notebook, make it electronic, make it available, put it out there. Define the difference between what you know and what you can implement, right? Some of that's driven by how many hands you have on for testing guys and all that. We're fortunate to be adequately staffed to take on more challenges. Everything can't adapt optimally at the same time. You have to understand your time horizon. I tell folks, always batch programs, never sit down and write one program at a time. Put yourself in a mindset there. And obviously never stare at a blank template. Try to fit them into an existing schema. If you have an athlete that is an early peak bimodal shortstop that you worked with 2 years who had great results, go back and look at that program along with some of the range of motion stuff and see it out. So
thank you, Eric. So for those of you who don't know me, my name is Ian Connors. I am the S&C coordinator here at CSP Florida. Prior to coming down here in 2022, I worked at a gym in Canton, Ohio for about 6 years. And my first boss in this industry was a Prezi speed school guy. Okay, so our facility was kind of known for our speed development, I would say, above all else. He was pretty deep in the football world. So that's kind of where my love and my interest in the speed side of strength and conditioning kind of started. I like to tell all of our interns here that this industry is very focused on the strength side of things. We're all, at some point of our lives or some point of our career, kind of been meatheads. We've loved the weight room. I am a firm believer that one way that you can separate yourself in this industry is having the technical knowledge and the coaching ability to actually teach speed at a high level. Now, how I would do that with, let's say, a track and field population versus a team sport population is going to differ. But a lot of these principles will kind of maintain across disciplines and across sporting endeavors as well. So Eric alluded to this a little bit in his presentation, but the ISA thing. So infrasternal angle, for those of you who don't know, it's basically a genetic predisposition to positions, postures, superpowers, and weaknesses, okay? So you have your narrow ISAs, you have your wide ISAs, and these two groups are going to excel at different things, okay? When we have this conversation, we are talking about the most narrow and the widest wide. And there's 8 point something billion people who fall somewhere in the middle, so that is a consideration to keep in mind. But your narrow ISAs, they're going to be ER biased, external rotation biased, okay? They're going to have access to both early and late stances during the gait cycle. And that's going to influence the biomechanics of a sprint to a certain degree. Because they have access to this very late stance, you might see a little bit more backside dominance in this group of athletes, okay? So they're going to be able to handle that position for a little bit longer than your wide guys. They're going to be a little bit more vertical dominant in terms of force production. So your narrows are going to be the guys who excel at the 400s, the 800s, the 1500s. If you look at the marathon guys, those are probably your narrowest narrows on the planet. They're not going to be quite as good at early acceleration, okay? Your wide ISAs, they're going to be IR biased, they're mid-stance dominant, they're force producers, okay? They're going to be a little bit better at horizontal force production. So your wide ISAs are going to be a little bit better at early phase acceleration than your narrows. I like to kind of describe these different populations using animals. I think it's funny, and I also think it kind of makes sense to a lot of people. So your narrow ISA is a little bit more elastic dominant. I liken them to kangaroos, versus your wide ISA is more strength dominant. Think gorilla, rhinoceros, all those big African animals, okay? So your narrows, again, I kind of alluded to this earlier, but they're going to be a little bit more efficient at top speed than acceleration. That comes down to the fact that, again, they're not exquisite force producers, they're much more elastic. So once you get them upright and their Achilles can actually do the work for them, they can capture that free elastic energy, they're going to excel. Your wides, they're going to be more acceleration beasts. So in the world of track and field, your 60-meter guys, your 100-meter guys, they're going to have a wider infrasternal angle than, again, your 400s, your 800s, your 1600s. The world of baseball, at least in my 3+ years here, seems to favor the narrow ISAs a little bit more than the wide ISAs. I would say we probably see more narrows than wides. In the college setting, it's funny, some coaching staffs actually tend to they're not aware of it, but they tend to prefer one over the other. Virginia, for instance, has a very different athletic population once we get them on the table than Alabama. But your narrow guys, so narrow guys, I mentioned ER bias, they're also going to have more thoracic rotation. Again, elastic whippy, when you're trying to throw a ball 100 miles an hour, those are all characteristics that are going to help you succeed. So coaching observations in my 3 years at CSP, working with the baseball population, a majority of our athletes are excessively backside dominant, okay? So what do I mean by that? They spend more time, their leg spends more time back behind the hip than it does out in front of the hip. Okay, so that's going to influence from a biomechanical perspective how the leg actually cycles through. You're going to see early and high heel recovery, especially in initial or early acceleration. That's going to change the way that they interact with the ground and apply force into the ground. Center mass is going to pitch forward just because they have all of this mass spending way too much time out back. And we're going to see basically a ground contact in initial acceleration that's not as efficient as we want it to be, okay? So we're going to see a little bit of forward foot speed or positive foot speed before ground contact versus negative foot speed, right? So in early acceleration, I like to talk about the leg cycle as a piston action, right? I'm flexing the hip up and I'm extending the hip back. I'm trying to get force into the ground, all right? It's not obviously pure horizontal force. There is a vertical component no matter what, but there is much more horizontal force application in acceleration than there is in top speed. So a goal of mine is basically to make it impossible to fail in terms of how I program for an athlete. So if I want to put them in a position, I try to do it with the program, I try to do it with the load selection on the 1080 versus relying on my audible coaching and cueing. I try to speak as little as necessary in order to get my point across, and I try to set them up for success in how I program for them. So I want to select appropriate drills and loads specifically on the 1080 to drive front side adaptation, clean up mechanics, and force application to the ground in all phases of the sprint, okay? Especially this time of year, my primary focus is absolutely on early acceleration and maybe getting into the transition phase of the sprint. As I get a little bit closer to the start of spring training, I'll get more and more into the top speed. I'll kind of drive velocity over that course of the off season. Some special considerations within the semi-private model of training. So prior to me coming down here, the gym I worked at in Ohio was more of a group-based setting. So you'd come in for about an hour and a half block, either train strength, train speed, right? So in my speed groups, I'd have anywhere from 4 to 10 guys. It's me and them on the turf for an hour and a half. That's my only focus. All my energy is going towards them. That's a little bit different than kind of our model here. So here, after we perform our initial evaluation, which Eric kind of took us through earlier, I have to sit down, we all have to sit down, and we have to write the 4-week program for the athlete. Now this 4-week program, it's all encompassing. It's everything. It's the warm-up, it's neural prep work, it's tissue prep work, it's the lifts, it's the movement days. The movement days are really our focus here today, because movement days are where we're going to train the speed stuff, we're going to drive work capacity, we're going to drive tissue quality, we're going to throw med balls, we're going to jump, we're going to do all those things. So I'm sitting down and writing this program knowing that there's going to be times where I might not see that athlete actually perform that exercise for 2 weeks, because I might be busy in the corner doing arm care with a circle of pro guys, right? So I have to try to predict how they're going to respond to the loads and to the exercise variation that I give them, okay? Experience matters the most when it comes to that, right? The more reps you see, the more you coach, the more you utilize the technology like the 1080, the more efficient you get at being able to predict how to properly set up that athlete for success in actual training. Program using variation and loading profiles to drive the desired adaptation. This is one thing I learned last year. I do try to stay conservative in initial loading profiles with our guys. And what I mean by that is, and I'll have an example of this later, but I had an indie ball shortstop actually last year come in around January. And the first month of programming, I wasn't really sure how he was going to interact with the actual forces in the ground contact. Narrow ISA, pretty loose, maybe 5'10", 180 pounds, undersized, needed to get stronger, needed to get faster, needed to be more agile and able in order to keep his spot on this team. But I wasn't sure how he could handle force. So I started him around the range of like 12 to 16 kilograms, I think, on the 1080, 10 to 15 yard sprints in that first month of programming. And jokingly, I had told him one day that with one of our NFL guys, one of our quarterbacks, I had ran him at 28 kilograms with extreme success. It looked beautiful. And that kind of lit a competitive fire under this athlete's butt. And he actually made me get the pulley out and maybe put the pulley on the 1080. And I think we sprinted that day at 28 kilograms. And much to my surprise, he handled that force incredibly well. There was no biomechanical breakdown. The ground contact times did not double, right? We didn't go up to 250, 300 millisecond ground contact time. We stayed athletic. It looked like a sprint still. But I didn't know that that was going to happen, right? So long story short, that first month, I like to kind of ease people in and build load just to see what they're capable of. Once I get a good idea of what that athlete is capable of, then I can really start to follow my progression, which we'll go through a little bit more. I do utilize what I would kind of call concurrent periodization here. If you take a large enough step back, everything is linear progression, right? But over the course of a program, I am training all qualities over the course of a week, right? What's going to change is the percentage of work or time, volume, that I dedicate to each one of those qualities over the course of an off season, for example, right? So work capacity, tissue hypertrophy, strength, power, sheer velocity, right? I'm doing all things at all times. I'm just kind of playing with those bar graphs over the course of the off season. I know there's a lot of debate about some of these subjects in the world of speed. I don't think there's really one way to do anything. I think the beauty of strength and conditioning and athletic development is that there really isn't a whole lot of black and white, and a lot of it is gray, right? So there's a lot of different schools of thought. There's a lot of different ways to achieve desired outcomes. This is just the way that I think about things. So my general kind of speed outline over the course of an off season with guys, I like to progress them from slow to fast. I like to progress them from heavy resistance to lighter resistance. And along with that, I'm going to progress from shorter sprints to longer sprints, right? These guys just played anywhere from 120 to 162 games. They need a break, right, physically. Like, they're gassed out. You talk to a lot of our big league guys, especially those last 2 to 6 weeks of the season, they're lucky if they get a lift in a week. Like, they're just trying to manage themselves, right? They're trying to keep themselves healthy. They're trying to keep themselves on the field. So I do want to build them up kind of a little bit slowly. My early off season, I'm going to prioritize addressing their weaknesses as much as possible. So acceleration versus the top speed, again, narrow versus wide, right? Narrows are going to be efficient at top speed. They're not going to be so great at acceleration. I'm going to hammer that side of things. I'm going to try to teach them how to apply horizontal force better. I'm going to try to strengthen up all the tissues of that lower leg and make sure that I'm not producing a Ferrari motor with a Toyota Prius tire, right? I want to make sure that they can put the power actually to the ground. They're safe, because not only is that going to help efficiency and speed, but again, just tissue quality and reduce the risk of injury, hopefully, as well. So early off season, more of a force focus. Late off season, I'm going to kind of switch over to just doubling down on their natural strengths. I'm always going to train those weaknesses, but a little bit more natural strength and probably a little bit more of a velocity focus as well.
So hopefully this will be a good synopsis of kind of the first two talks. I'm going to talk more kinetics, whereas they mostly talk biomechanics and kinematics. This will be more ground reaction forces, which is my bread and butter with the force plate, kind of describing how the 1080 can actually be used as a horizontal vector force plate, which we've got more into as we've been lucky enough to open up our biomechanics lab. So for most of the time in weight room, people are looking at vertical force vectors. Obviously, force plates measure vertical force into the ground to measure jump height and all the sorts of metrics that any of you guys look at. But obviously, in sport, it's not just vertical force. There's horizontal, there's medial, lateral, anterior, posterior, and then every vector in between. So when looking at the 1080, it offers a little bit of a different view, especially when you're measuring things. So it can't be made, so I hate the term force is absorbed for decelerating. I think you always are creating force. Force production is triplanar, so X, Y, and Z. I'm going to reference horizontal force as X force today. I know X and Y could be different depending on what lab you're at. But for us in our lab, with our mound force plates, the X axis is horizontal. Okay? And then for today, I know some people look at Y force. We're going to talk 1080 in terms of the pitching delivery. And when you're talking about anterior posterior force, Y force in our case, that's a negative predictor of ball velocity, so we don't want that. And then obviously, like I talked about before, force plates can be used to measure vertical force, whereas 1080 would be a horizontal force vector. Just a little visual so you guys can kind of see exactly what I'm talking about when I'm referencing this stuff. These are screenshots from our lab over on the other side of the building. Z force is going straight vertical, and then X is going down the mound horizontally. So obviously, Z force and X force partake in the back leg pushing off the rubber, and then the front leg decelerating into ball release. On the top, you see kind of screenshots of what a pitcher would look like going through their delivery in our lab, and then the bottom would be a horizontal force vector. Sorry if this is a little small, but X force translates up on a slow incline as they get off their front leg, and then in the actual front leg, it would be negative velocity and force down here. So kind of just a slow picture of what it would look like from like a force velocity, force time curve standpoint, similar to what EC was showing you guys earlier with our force plate stuff in the gym. So quick physics, law of conservation of energy, kind of like I hinted to before, force can't be just like made up or absorbed. Energy initial equals energy at the end. So obviously what gets put into the ground could somehow find its way up to the ball if everything is efficient and timed up well and sequenced well in the right order. So obviously the force that you put into your back leg should be transferred into your front leg and into the ball. Obviously not all that force is going to get there. How you do it, the moves you make, the timing that you have dictates how much of that actually goes into your hand and into the ball. How do you get more efficient? Obviously Eric kind of hinted at the different types of force time curves that we have with our force plate. You can obviously have similar things when you look at the 1080 and you break down hide-ins or jumps or broad jumps, you get the force time curve as well. So some different things that we utilize, change of direction drills, agility drills, the 5-10 that Ian kind of hinted to. Plyometrics may be debatable on the ground contact time as to what you can actually utilize with the 1080, probably more assisted stuff. Ballistics, high load, low velocity, low load, high velocity, any sort of combination of the two, depending on where the athlete's at. So obviously, the bottom graph, that guy's getting crushed by gravity. The top graph, that's at a pretty elite MLB player up top. We want to take that high schooler on the bottom, make him more efficient so that he can look like that guy up there, using any of the strategies to the left. So now I'm just going to go through a couple quick ways on how we utilize this. We don't do a ton of different sorts of stuff that I'm going to show you, to be completely honest. We do utilize the Sprint 2 for more of sprinting, change of direction, bounding, more of the stuff that Ian talked about. This is more theoretical as to how it can be applied. So staggered stance, assisted to split stop. This is a simple deceleration drill that we utilize. If you do this assisted, obviously it increases the amount of horizontal braking force it takes to stop your center of mass, which can increase the amount that you can actually utilize when you play your sport. This is the 5-yard side shuffle, the change of direction sprint that Ian had mentioned earlier. Again, just a simple change of direction drill, but the 1080 can increase the amount of horizontal force, that braking force that it takes to stop your center of mass, change direction, and go in the other way. 1080 resisted broad jump, so super simple one. I use this a lot with my personal training clients because I can actually be one-on-one with them and actually prescribe the loads and velocities that they get, and you can track power output, and they love that. But again, a loaded ballistic to increase overall power output. But again, using this as opposed to a kettlebell or a sandbag or even a band increases the amount of horizontal force that you need to produce into the ground to go forward. Assisted forward leap to one leg landing. This is a slight variation of another drill that we do. So half of a broad jump, it's not a full broad jump, into a one leg landing with a stick. You are loading the vertical vector as well, but this is again overloading the horizontal force vector, similar to a pitcher going into their lead leg block, to overload the amount of braking force that they need to stop. So this would be a resisted lateral hide-in with the ER stick, a typical skater jump, or hide-in as it's called. We have a variation where they open up and land into external rotation. This looks pretty similar to what guys do on the mound, so you can get super specific with the way that you load it. So again, it's a loaded ballistic into unilateral lower body power output exercise. Obviously, theoretically, you're loading the back leg and unloading the front leg landing. You can also do this one assisted. This is a very advanced exercise. I probably wouldn't give this to too many people, as the 1080 is actually pulling you in the air. But again, this is a great one for if somebody, high-level athlete, has a poor front leg. It increases the amount of amplitude of horizontal force that they need to be able to stop themselves on that front leg, and unloads their back leg to get in and out of positions faster. Back leg, low force, high velocity. Front leg, higher force, higher velocity. This would be the end goal for me to get every pitcher to, in terms of like a ballistic or a plyometric, using that. Why is all that important? Why are these good? So this is kind of a rabbit hole I went down probably 3 weeks ago with the force plate, before I had even thought about exactly what I was going to talk about here. Once we got the force time curves from the lab, we've had 20 guys throw on it, so maybe this is like the first couple. The top graph is a vertical force production force time curve, and then the bottom one are two different types of jumps that I did on the counter movement, or on the force plates. So the green is obviously their back leg. The red is their front leg once they land. And what you notice is the back leg looks super similar to a right leg. This is a right-handed pitcher, a right leg counter movement jump, and the front leg looks super similar to a left leg drop jump, which is obviously that's what happens when they throw. They start on their right leg and then they land, for lack of a better term, on their front leg, have to stabilize, and then put force up into the ball. So with some of my pro guys, I'm getting super specific on the tests that I'm doing on the force plate to track what actually shows up visually on the force time curves in the lab on the mound. And believe it or not, it kind of shows up when you look at horizontal force time traces as well. So this is a back leg and then a front leg graph horizontally on the force plates on the mound. And then the bottom is a right leg hide-in from a right-handed pitcher. Visually, this is a couple different reps from him and then one pitch at the top. So you do see a steady increase in force as he gets off that front leg. It looks a little bit hairy. It should probably stop right about here on the hide-in one. But visually, they do look similar, so I think that would be a good utilization of that test with the 1080. So why does all of this matter? Why is it better to have a unimodal graph? Why is it better, not as good, to have a bimodal graph or more efficient hide-in? I think it just comes down to, at the highest level of competition, when these guys are making moves at 7,000 degrees per second, like, efficiency matters. So this is one of our guys that we had in the lab the other day. He was sitting 92, 93, 92, 93. His last pitch was 94.8 or whatever it was. It's like, why is that one different? Dom and I were going over the other day. When you look visually, these two graphs look very, very similar. But what you'll notice is on the front leg graph, on the top one, which was 94 miles per hour, the rate of force development and the steepness of the curve is much steeper than the bottom one. So him being able to stop on a dime, produce force into the ground to stop himself quicker, more efficient, faster, and quite literally more force. It was 2 times body weight as opposed to 1.8, was the difference in 1.5 ticks. And at 35 years old, he's looking for another job that matters. When it comes to horizontal ground reaction forces, the 1080 is probably top dog and king. We haven't done, truthfully, a ton of testing. We're going to start as guys start getting back. But again, if we're talking X-force, I would look at the 1080. Again, force plates have kind of conquered Z-force. But 1080 would be a good tool to look at X-force. So further exploration, obviously. I think force time curves from Haydn's could be similar at some point to what Eric talked about when we're looking at force time curves from CMJs on the force plate. Anything that you can create that looks similar to the task that they're competing in would be a beneficial thing to look at. So obviously that's why I changed some of the jumps that I do on the force plate, and why some of the force plate or some of the force velocity profiling on the 1080 would be beneficial with the Haydn. And then creating norms and archetypes and everything in between as far as what the graph shapes looks like would be the next frontier as well. But yeah, that's just how I think kinetics could be improved with the 1080.